Hi, everybody. I think I know most of you in this room. But I'm a front-end developer at Yale ITS within Campus Community Technologies. And so today, my presentation is about whether your website or application is slow, and really talking about website application performance. This is probably more of a general overview of kind of website performance, how sort of network requests work, how sort of things load within the browser. So what is web performance? I found a couple of definitions, one from Wikipedia, one from Google. The first one kind of refers to the speed at which web pages are downloaded and displayed on the user's web browser. So when you think of that part of the performance, it's how items are coming into the browser, how they're downloaded, how they're requested through the network. And then the other piece of it is the objective measurement and perceived user experience of load time. So how the actual user sees what's going on the screen and how they perceive the performance to be. So why is it important? Well, if we build something, website application, and we have end users, we don't want it to be slow for them. We want them to be able to, have it be performant, not have them be frustrated, not sort of leave. In website world, usually you look at a bounce rate. So if your website is slow, you may lose users that are coming to your site. This is especially important if you're selling something. You can potentially lose revenue if your websites move slowly. And for some users too, if international users, or if you're even traveling out of the country, you may have to pay for megabytes of data, that you use. So this is just kind of a basic overview of how a web page loads. Your browser, you type in the address. This is kind of very basic, but it goes to request assets. A server processes the assets, and then it brings it back down to the browser window, and then the browser begins processing those to show them to you on the screen. And so what happens is it actually does what's called an HTTP request. So it goes out and it requests that resource with commands to say, I want to do this, I want to get this resource, I want to get an image, I want to get a page. And there's two types of HTTP request versions. I just kind of wanted to briefly touch on it because HTTP 2.0 is the newer version, and HTTP 1.1 has been around for quite a while. But 1.1 really had a limitation of how it could request resources. So it could potentially go to a URL. Let's say Yale was still using HTTP 1. And say, give me 3 CSS files, 2 JavaScript files, and an image. And if there's more images, more files, it would actually only process 6 of them in parallel at a time, and then have to re-request the next 6 until it got through. Now, this was domain specific, so if you had Yale.edu and Google.com, it could process those in parallel, but it had a hard limit of 6 per domain. What HTTP 2 does is it allows what's called multiplexing, which will allow you to just kind of have one single connection that will allow you to bring down multiple assets at the same time. So those 7 would actually start potentially at the same time based on how the browser loaded. And we'll see that later on, how the different HTTP versions download assets. So there's kind of 2 aspects to think about in performance, the back end and the front end. The back end is usually what is the server doing, how is the server taking in data, how are the network requests coming in, how am I querying the database, potential file upload, storage, that sort of thing. And then we look at the front end, which is really what the user sees, the HTML, the CSS, JavaScript, images, interactive elements, things that they could press, things that they could do on screen. So usually when we think of the back end, it's usually like, if you think of Drupal, when you're installing your Drupal modules, the back-end components of those are kind of what's loaded into the system. But usually if you're doing an application, you're writing code in Ruby, PHP, Python, and that's kind of what the back-end processing is for there. And so usually when you're looking at the back-end and you want to optimize it, you're going to look at a few different layers. So you're going to look at the application. Is there anything inside of my code base, or my framework that I could do to make sure that it processes data quicker, that it runs faster, and then also caching as well. So for our Drupal instance, there is a caching layer between the actual backend application and when it gets out to the user. So if a file or a web page, put the battery in. If a file or a web page is requested and the file comes back, instead of, it'll go to the back end one time, grab the data that it needs, and then come back out. But with the varnish, it's called the varnish cache, it'll actually process, the varnish will actually stop it from going to the back end and then send that data back. And the good thing about that is that the speed of the caching layer will actually help to get the data down faster to you. So whatever you can and whenever you can cache, you should do so that you can get the data back to the user faster. There's also database level caching, so sometimes you can cache if you have database queries that are running, multiple ones, you might be able to cache those as well. And kind of like what Franz talked about this morning in the keynote about how Yale sites were, fast around the world. Well, that's part of what's called a CDN, a content delivery network, which allows you to kind of do that varnish server caching, but at different locations, potentially around the country, around the world, so that those assets are actually closer to the end user and that the end user gets those in a lot quicker to their location. So rather than going, if you're in Japan, you don't have to go all the way to the US and then come back with that data. You might be able to have a local CDN that's a lot closer to you and cut down the trip time as well. And there's also some other things you could do, which are scaling. So you can increase kind of the hardware that you have potentially on a server. So if something's going slow and the processing is taking a long time, you could say, okay, let's just add more memory, more CPU, more disk space, and hopefully that helps. You can also, and that's called vertical scaling, you can also horizontally scale, where you say, okay, instead of one server processing, let's add more servers that will be doing the same thing and distribute that load among them so that the application processes faster and can get you a response back faster. So some back-end tips, N+1 queries. So kind of a very basic idea is a lot of times in application frameworks you'll have a database, and let's say you have a user table and the user has a lot of posts that they do. Well, a lot of times what people do is they will query and say, get me the user query is ran, you get data back, and they'll say, get me the posts. But what actually happens a lot of times is it'll run a separate query for each individual post based on how the software was coded. So you may have 6, 7, 8, 10 queries, and those keep sort of, when you go to the database, it's a little more expensive in terms of network traffic, which could add load time to getting a response back. So, but one idea would be combine the user and the post into one database query and then bring that back down so you don't have to spend as much time querying the database. And you can also cache the queries that you run frequently. So if you're running the same thing over and over again from the database, just get it, if you can cache it somehow, then you could just get it back a lot quicker to the user, or even cache the output, the full HTML or whatever you're sending back response of the data. If you can cache that as well, that'll get back to the user quicker. And that's kind of what the varnish does, is it says, I see this output that's created from Drupal, I'm just gonna send that back down every time. And then also look at like servers, hosting providers. If you decide to host a site like on GoDaddy, the performance may not be there as well. So, depending on what you're doing, you probably want a good provider. And also you could send asset files to CDN. So if you have, JavaScript that's compiled, you could say, put this on Amazon S3. That might be faster than my application server as well. So the front end is usually what gets displayed to the user. This kind of contains your themes, your layouts, usually interactive JavaScript files. And so this is kind of the time for loading and time for displaying content could vary. If you have a lower end, phone versus a high end desktop, the loading times will be significantly different among different users. So some front end optimizations are when you send down files, you can actually tell browsers to cache them and say, I don't want this constantly, for the browser to keep coming back and getting the same JavaScript file over and over again when it hasn't changed. So you tell the browser, cache this for maybe a day or a week or a month. If you're updating frequently, maybe set the caching a little lower. And then you can also minify and concat files, which is currently what all the Drupal sites I think at Yale do by default. It will actually, if you have this huge file, it'll actually optimize it and minify it down, and also concatenate it. And what that does is, if you have 10 JavaScript files, it may put them into one, and then send that down back to the user. Now, the concatenation is actually only good really if you're using HTTP 1.1. The reason being is, if you remember back to the previous slide, you can do about 6 requests at a given time on HTTP 1. The issue, so if you have, instead of 10 files where you're doing 6 and waiting for 4, you can just send one larger file down, and it'll be slightly faster. With HTTP 2, you can actually have multiple files over one connection. So you still want to minify because it's still going to make the file smaller, but you don't want to concatenate because there's it would actually be faster to have the multiple files going down instead of one large one. You can also do gzip, which I'm not going to get too much into, but it allows you to kind of, zip up the file a little further for the browsers, and then optimize your images. And this is a big one. The one thing you want to try avoiding is having these large images come right down to, to the user, and that's almost always where you see the bottlenecks. At least on the initial view, is you're getting these large, JPEGs or PNGs, and those are the things that take a lot of time for the user to review. And then you can also do some CSS optimizations, remove unused CSS, remove unused JavaScript, so that it doesn't, it just adds extra load to the page. And that was the first front-end tip. Remove 404 requests, or remove, file not found requests. So, if it has to go to the server and says, oh, this file's not here, that's just going to add extra load time to the front end, which is really unnecessary. Smaller images, you could also do something called lazy loading of images. And what that does is, let's say you have some images that are further down on the page or in a carousel or something. Maybe when the user goes down to that part of the page, the image begins to load at that point. So that way they're not waiting for, on the initial page load, for that image to come in. It could just come in later on as well. And for front-end frameworks, kind of similar ideas. You could split code up by JavaScript code that may be a little bit heavier up into routes, so that when a user gets to a certain part of the application, it'll load it. And then if you have like components that are constantly rendering within a front-end application, you can kind of try to limit the amount of times that the JavaScript has to process or re-render. So we'll take a quick look at the load process. I have a neat graphic. But some ideas when you're talking about performance on the front end is there's a few terms that you probably want to know. I kind of highlighted the 3 ones that I use, but you have time to first byte, time to first paint, and time to first meaningful paint. And time to first byte is when I send a request, when do I get that first byte back? When do I get the first piece of data back? And if you're going from across the world versus into your local area, the time to first byte is going to be a lot longer, and the user has to wait a lot longer. Time to first paint means when the actual first items start painting on the screen, start painting inside of the HTML. And then the time to first meaningful paint is the first items come on the screen that the user may actually be interested in. And let me see if I have a good graphic of this as well. Let's see. So if we could see, we have, this is kind of the life cycle of a page load, right? So this is on a phone, but the page loads, there's nothing, right? You're kind of waiting for the data to come in. First paint is when it starts to actually show on the screen. First contentful paint is kind of the first piece of, maybe the first graphic or whatnot. But first meaningful paint is, okay, finally we see on the screen that there's like data that the user can use. And then timed interactive means that the user can actually probably scroll up and down on the various items. So this is kind of important, I think, to understand is how is my actual web page, application page loading, for the user when they actually come to it. Okay. Any questions so far about that graphic or how a page loads or anything of that nature? Okay. So I'll just quickly go over this. This is kind of Google has what's called the rail model. It's response, animation, idle, load. And this just kind of quickly go through. But response is, you want events that are done on the page. Like if you click something and you need a response for it, within kind of the JavaScript model, you want it to just kind of quickly respond within 50 milliseconds. You don't want somebody to hit something and then it just like chugs on forever. Same thing, similar with animation. You don't want, an animation frame to take forever to load and you see a sort of choppiness that the user is viewing. Idle is maximize your idle time. So if there's other things that can be done while the browser or the phone or whatever is kind of idle, utilize that time. And then load. Make sure you try to deliver content and become interactive in under 5 seconds for the user. So this is kind of Google's model for what they have for kind of the Rail model for kind of how a page should load. And so just a couple more tips for optimization techniques. Make sure the file sizes are not too large. Optimize your images. Use SVGs if possible. So if you have a logo that you can convert into an SVG, rather than having it go up and get another image and come back down, maybe you can use an SVG, which is just potentially loaded right within the content. And then minify, concat your files, and then use a CDN for files where you can. So I'm sure some of you use Drupal as well, and these can actually kind of apply to other CMS systems. We just use Drupal here, but the big one that I think you can start doing today is don't upload images directly from your camera, from your phone, right into the website. You plug the phone in, or you AirDrop, or you whatever, and then you just go, okay, I'm going to upload this. Well, your camera or your phone is probably set to high resolution, high pixels, so they could be 5, 10, 15, 20 plus megabytes, and if you're somewhere far away, that's going to take a long time to load. If you're paying per megabyte, if you go internationally and you're paying $15 a megabyte for a 20 megabyte image, it's going to start to add up and you won't be happy when you get the bill. So that's probably the biggest thing, is always look at the image size. That's probably the biggest win that you can get for increasing performance. With Drupal, be careful, and I'm guilty of this as well, be careful of enabling too many modules. On Drupal 7, Drupal 8 may be slightly better with it, but it'll actually go to every module. It has certain lifecycle hooks in it, and it'll go to every module and say, hey, do you have something that you need to process for this hook? And if you have a few modules enabled, it's not too bad, but the more you start enabling it, the more it has to go for each of these hooks, and then the longer it will take to process on the back end. So ideally, it will take a lot of time to process, but then subsequent requests will actually be cached in the Varnish server and then sent back down to the user a little faster. Don't disable caching in Drupal, for certain pages. I know there's ways to do it, unless you absolutely have to do that. And then if anybody uses views here, look at your view configuration. If you're loading in 10,000 records with no pagination in your view, or search or whatnot, that's going to take a lot of time and have a lot of load on the server, especially if you can't cache that specific request. So make sure that you're not, getting kind of too crazy or joining a lot of tables with the views. You want it to be as simple as possible. Here's some tools. Network Inspect tab, that's the big one. That's the one I recommend everybody uses to kind of review, and we'll take a look at that. Lighthouse is also in Google Chrome, and that has the ability to do some analysis as well. And then Web Page Test is a really cool one. Similar to the Network Inspect tab, it's a website that will actually go from different areas in the world and tell you how your site would perform in that specific region. Some other ideas. So you can also actually prefetch some resources and say, I'd like to fetch these ahead of time. And kind of, it would actually give the ability to store some of those different items. Local storage, you can store certain pieces of data, key value pairs, within the actual browser for later use, so you may not have to go out to the website and get them. And then I'll talk a little bit more about progressive web apps, which kind of allow you to have almost like a native mobile-like feel for certain applications, and accelerated mobile pages, AMP as it's called now, which allows you to kind of use Google as a CDN to deliver your whole website experience, or your whole web page experience, I should say. So I spoke briefly. Oh, and the neat thing about progressive web apps is that you can actually have features to work offline as well. So you can actually save certain assets and resources, so you don't have to go back to the network if you lose a network connection. And the AMP project, which is launched by Google, actually allows you to format your web page with certain HTML. It's a subset of HTML, so you can't use every single tag or every single piece of JavaScript. And what happens is Google will see that it's an AMP page if it's valid, and actually in certain mobile queries will serve it from their own domain, And the idea being that their CDN, their domains will actually load faster than your own web page, and the idea being to give mobile users faster speed when loading websites. So, and then we'll look at some demos. Any questions so far? No? All right.
How does Google deliver your content from their server?
I'll show the demo, but what they do is you mark up your web page with AMP. Usually you have my regular HTML version, and then you have an AMP version, although you don't have to, but usually that's what's done. And Google will see, oh, this is valid AMP. We're going to catch it. We're going to index it. And when you do a Google search, it'll actually use the AMP version of the page. And then when you click on the link, you're going to google.com/AMP, with the rest of your domain, and everything is served from Google. So it's made to look like your website, but technically it's coming from Google. And usually you see like news organizations do that. I think you need to use AMP to get in the news carousel. If you ever do a mobile search on Google and you get the news carousel, you have to be AMP. It has to be an AMP page, and you have to be like a news organization to actually get on there. All right, so let's take a look at a couple of the demos. Oh, actually, let's also look at, before that even, let's look at image performance. So, let's say I got this image, I get this off the, I forget, one of the Yale photo sites. So let's say I wanted to use this on my website, right? So this is actually a fairly large image. It's about let's see if we get info, 3.6 megabytes, or 4.2 megabytes on disk. That's fairly large, right? There's no reason to really send that down to the user in this size. I think it was like 6,000 pixels wide. So the idea being is that you want to optimize this image. So I open this image in Photoshop. I can actually look at the size of it. And it says that this is 6,000 by 4,000 pixels with 300 resolution, which we really don't need for a website. If I were sending this off to a printer, file sharing, that'd be fine, but I'm not. So in this case, what I'm going to do is I'm going to set it to 72 resolution, and if I really want to capture the wider screens, let's say I set it to 2,500 pixels approximately. All right, we're going to resample it, and then Photoshop has this feature, although you can use other programs too, that has export, save for web legacy. They call it legacy now. But we can actually say, okay, at 100% quality, it should give me an estimate. It's going to be about 4 megabytes still, which isn't great, right? But if I do a JPEG high, which it goes down to 60%, it gives me about 1.14 megabytes. And if I were to go down to 30%, it's about 585 megabytes for what the user would be sent. So let's look at the original photo, right? Let's look at the high optimization at 60% quality. And let's look at the 30% quality. So let's compare the 60 and the 30. Maybe that's a little better. I don't really see, maybe someone can see it between the two. Is there really a difference in quality between the two images? So there may be as you keep going down, right? Or some, like if you're audiophile, like you tend to hear it for vinyl versus not. But play with it a little bit. See if you can kind of get it down to a size that would fit whatever the content area is that you're doing. A little trickier with slideshows because they may want bigger sizes. But get it down to where it's it doesn't degrade the quality, but it's still good enough for the user. But it's still the size is good for the user to be able to download it. All right, let's pull up Chrome. Let's take a look. So one of the cool things that I use is called the Network Inspect tab. So if you right-click in Chrome and you say Inspect, you can actually look at what's called the Network tab. Oh, we're going to remove mobile for now. And I'm going to do a hard empty cache and hard reload. So I'm coming to the Yale.edu site for the first time. And what this gives you is what's called the network performance. So I'm going to I'm going to do waterfall. And this actually shows you, can everyone see this? Okay. So this will actually show you how your web page is loaded. So if you look, it's going to load the yale.edu HTML document first. And then you could see, oh, okay, it begins to load all the rest of the, the pieces of data that it needs, the JavaScript, CSS, external libraries, whatnot. Sometimes it'll actually below give you profiles. So on this connection at 3.5 megabytes, it transferred. It took about a second to get all this data down. Another thing to remember too is, we're at Yale. The connection's pretty good. If you saw the network talk, you could. They're upgrading even more. Most users will not at home. If you're targeting the public, will not be on this kind of connection, especially on a mobile device. But it's still good to see, because this could show you potentially where are my bottlenecks, right? What's taking forever to load? So first thing I usually do is go size, right? Descending, and I see, wow, there's one image that's 1.4 megabytes. That seems to take a little longer to load. Is it possible maybe to optimize this image, right? Can I get it to a smaller size? But if you look too, we could see with the HTTP 2, there's another tab. If you right click, you could select the protocol that will actually show you whether this is using HTTP version 1.1 or version 2. And we could tell the difference too. So I'm gonna, and this is nothing against Dartmouth, but I use them as an example because they have they use HTTP 1. And their site's still fairly performant, so there's nothing really wrong with it. It's just, but as you could see, right, they're doing about 6 network requests in the waterfall, and then everything else is kind of getting pushed off. So it's kind of getting the 6 files, then going to the next 6 files, and going to the next 6 files. So that's kind of what an HTTP 1 request would look like, whereas the one using the HTTP 2, it allows it for kind of a little bit better throughput. So where you can, when possible, try to use HTTP 2 as well. Just make sure it works on the older browsers or whatever browsers that you're supporting. It also gives you a it'll also give you a profiling tab above it to see how the site begins to load, like what pieces of content are coming in. Again, maybe different for different browsers based on how they render. But this gives you kind of a good, if we remember before how we had the first paint, first contentful paint, first meaningful paint. And the good thing too is as I go, so I've loaded all these resources, as I go through the Yale site, the the load becomes finished 850 milliseconds. I don't know if I can get rid of this. Because we look, a lot is coming from disk cache, memory cache, so caching headers were sent with it. So as we're going through the site, the files that have already come in will actually be cached on our website, so that they don't have to keep going out and getting it, and that any new content on the page is what they will actually go out to the network and get. So all right, so I just want to show you an example. Although great job on the digital conference website. If we look. Actually, let's do an empty cache and hard reload. You can kind of tell there's one image that's 8.8 megabytes, which probably for this instance can be reduced down to quite a few quality and probably the size of it. I don't know if we can see what it looks like, right? I mean, I don't think we need you don't need this whole large image for that. So that's one thing to look at. Is usually the easy wins are, can I reduce the size of this? Because especially like when I was at home and I was loading it, you can noticeably see the image coming in on a slower connection. But great job on the digital conference site for those who worked on it. Okay. So webpagetest.org. What it allows you to do is kind of like the network tab, but from different areas in the world. They have a huge list. Can anyone see that and want to pick a site somewhere in the world? In a place they like? Where? Prague? Where's Prague? Oh, there we go. Okay. And do you want to, let's see what browsers they have available, because it'll allow you to do different browsers. You have Chrome or Canary or Firefox. Which one do you? Chrome or Firefox, really? I think Chrome. Okay. So we can start the test. And while that's running, it may, depending on load, take a little while based on, because it's a shared service, but it is free. I highly recommend any website or application you own to try to do this. But it gives you so this is from Dulles, Virginia, which is East Coast. It'll give you this kind of nice waterfall diagram in depth. As we can see, the HTTP2, all the requests are coming in. And then it tells you, okay, this is when it started to render. This is when you became interactive after 2.5 seconds. So great job, Yale.edu. It will show you whatever external libraries you're loading, how they load. But you can see here, right, this 1.4 megabyte image took a little bit longer to download because it was a larger image. It's a load time, about 6 seconds. Where else did I look? Tokyo, Japan. Okay, so from Japan, still pretty good loading time. That larger image took a little longer. I can't tell from this, but it most likely is hitting an edge CDN in Asia to pull that in. And to finish, so here from Prague, and it usually does a couple runs, but yeah, not bad. The reunion and the larger image took a little longer to come in. But everything loaded fairly, actually 1.5 seconds. So they must be using some edge CDN in there. And that's kind of when it started to render. So it must have had the resources necessary to render at 1.5 seconds. And I think, and this is Mumbai, India, similar type of thing. So this is pretty neat. So this will actually allow you to see where there are bottlenecks within your application that you may be able to fix, at least on the kind of the network end. So if you remember before, we talked about progressive web apps. So I'm going to show you an example of one. This was for the Yale School of Medicine. We built an application that was going to be delivered at pediatricians' offices on an iPad. Oh, yeah.
Yeah, and then just before you get to the next
Yeah, of course.
So are images like the number one bottleneck when it comes to loading images?
They are probably one of the easier ones to fix. That you can kind of, because if you do database queries or image or CSS concatenation, minification, those are a little more trickier to kind of assess. The image one you could just kind of find very easily, go into Photoshop or other tools and resize and kind of redo what's needed as well. Yeah.
So if the file's going to the CDN and the file large, how do you control this?
Well, the CDN has to have a source, right? So it has to get it from somewhere. So if you're giving it a smaller file size, the CDN will have the smaller file size as well. So it's kind of whatever you give it. You don't usually the CDNs, you don't put them specifically on there. The CDNs will pull down what it needs to and then serve that out. Any other questions? Okay, so this is actually a browser app that we built as a progressive web app for the School of Medicine. They were going to give this out in pediatricians' offices, and people would be able to tap, click, get some information. And the one concern was, well, is there Wi-Fi within pediatricians' offices that's always working? Because the problem is it would go, maybe load the images, but then would it actually, if they went to an area where there wasn't Wi-Fi, we didn't want this thing to crash. So we did something called Prefetch, which actually allows you to, and using the service worker, allows you to store network requested files locally on the device. So I'm going to do an empty cache reload, and this may or may not work, hopefully. But if I click around, I'm connected to the network. I see some items. Right, we go home. What I'm actually going to do is go offline. So there's a little tab here too, which is nice. You can actually go offline in the browser. So there's technically no network right now. So let's see, may or may not work. But so I'm still getting, this is all data pulled in from Drupal. So I'm still getting the Drupal data. It broke. Okay. So the idea being, this image was never loaded by me, right? I never went to this page before. But because with certain techniques, I was able to actually grab that image I knew was coming in, preload it, and save it within the actual, and on the iPad it works a little better, but save it within the cache of the device, so that this, if we were to move to a different Wi-Fi area, I would still be getting this data coming in. And if we look at the network requests, if you see at the very bottom for the images, it's saying from disk cache. Even though I never technically loaded them in the view, it actually went out, did network requests for them to prefetch and save them kind of within the device data. And then let's take a look also at an AMP example. So this is okay. So this is a CNBC article about Yale. I took my most popular class ever, and this is kind of the regular CNBC website, article. And as we can look, let's see. Hopefully this works. But if you look at the URL, you can see that it's from cnbc.org, right? And so all of their data is coming in from, if you usually hover over it, you could see it's coming from CNBC or one of their CDNs. If we look at this is the AMP version of that same article. So same article using the subset AMP HTML. And ideally the load would be a little faster. But this is kind of, it looks like a slim, even though they're similar, it's actually a slimmed down version. But all of it, I know it's kind of hard to see the hover, but it's actually coming from cdn.ampproject.com. So Google is actually hosting all of those assets. And the point being is that when you're on the mobile, I've searched for Yale, I've gotten this article, I click on it, I'm getting an AMP version that loads super fast so that I don't abandon the news article. And it's kind of really Google's initiative to have it load faster for users. So.